Hi everyone. In this video I will be explaining how to find a particular antiderivative. In the previous lesson we studied how to find antiderivative. Remember when we find any antiderivative we added c at the end because we don't know what the constant is. So in this lesson we will be finding that c, specifically that c. If we are given just a little more information, we can identify the value of C specifically. Now let's take a look at the questions asking about the exact specific function, exact specific antiderivative. Okay, first thing to do is take an integral, like we did in the previous lesson, and substitute the given point. A point will be given in these type of questions. We will be finding C easily. The first question, exercise 19. Find a function knowing its derivative is 2x minus 1 at 1, 1. So derivative is given, our point is given. All we need to do is, remembering the idea of integral. Integral means antiderivative means inverse of derivative. So when we take derivative, we actually find the original function. We are looking for f of x where f prime of x is given. Right? This is the idea. We put the derivative inside the integral symbol and original function will be found in this way. Now, what is the derivative? 2x minus 1. Now, derivative of 2x is, integral of 2x is increase the power by 1 divided by the same power minus for 1. The power of x is 0, it became 1 power 1 and plus c. Now our function is x squared minus x plus c. Now I don't know what c is, but it's not a big deal. I know the point. I'm going to use this point to find the unknown. What does that mean? One means x, the other one means y, which is f of x. So substituting 1 for x will result in 1 as an answer. So 1 is equal to 1 squared minus 1 plus c. So 1's cancel each other. C is equal to 1. So I can write the original function. My function became x squared minus x plus 1. That's it. So I got my function without c, without writing c, with writing its original value. Okay, so this is the way of solving questions. Another question, an original question, exercise 31. This time we are asked to find f when f double prime is given. So we're gonna do the same twice. In order to find f, we need to know what f prime is. In order to find f prime, we need to know what f double prime is. So f prime, first of all, is equal to integral of f double prime. Right? So let's find f prime first. F prime of x is equal to integral of f double prime, which is 2x. That's gonna be 2 integral of x is x squared over 2 plus c. So x squared plus c. Where, what is the point? Question says it has a horizontal tangent at 2, 0. Meaning, remember from chapter 3 what horizontal tangent is? The derivative being equal to 0. Derivative at 2 is equal to 0 when there is horizontal tangent line. Remember? So the point is 2, 0 at derivative, at first derivative. So now my y is 0 while my x is 2. So 2 squared plus c, which means c is minus 4. So I got my first derivative. F prime of x is x squared plus c, which is minus 4. Okay, I got f prime. I am not done. I'm looking for f of x, the original function. Let's repeat these steps one more time. In order to find f of x, we need to take the integral of f prime. So my f prime is x squared minus 4. Take integral of each term. Integral of x squared is x cubed over 3. This is 4x plus c. What is the point? The point is the same point actually, because if there is a function uh, and it has horizontal tangent line at 2 0. Let's say here it has a horizontal tangent line. So the original function is also passing through this point. Okay, if the derivative is passing through, if the tangent line is passing through this point, original function is also passing through this point. So we have a common point here. This point 2 0 is common for both horizontal tangent line and the original function. So we are going to be using the same point 2 0. X is 2, y is 0. So 0 equals x2 cubed over 3 minus 4 times 2 plus c. Now calculate c. We're gonna have a fraction. I'm not doing the steps here. You can isolate c easily. Bring everything to one side of equation. Leave c on the other side. So you'll get c as 16 over 3. Now my original function becomes x cubed over 3 minus 4x plus 16 over 3. Okay, it's a nice question, and there are similar ministry exam questions. Another type of question, graph questions, study guide 22. Which of the graphs given below is that of the function f, knowing that f prime is 2x and f of 1 is 4? Okay, I'm given the derivative. I'm asked to find f when this point is given. Just like the other questions, we will solve this question by integration. Okay, f of x equals integral of f prime of x. So it's equal to integral of 2x dx, which is x squared plus c, right? I have a point, 1, 4. So let's try this point in this function. Your y is 4, which is equal to x is 1, 1 squared plus 4, so c. Then our c is, moving 1 to the other side gives me 3. So my function becomes x squared plus c, which is 3. So look at the graphs. Which graph? We have x squared plus 3, not this. This is x squared, just x squared maybe. If it is not parent, there is a transformation. There is a stretch or compress. But this one is, yes, x squared plus 3, 3 units up. So this is the correct answer. Just like this question, we have a ministry exam question. All right, let's continue with another ministry exam question. Idea is same again. F prime is given. We're asked to find f of 1 where this point is given. In order to evaluate a function at a point, at a value, we need to know its function. In order to find f of 1, we need to know what f of x is, right? We don't know what this is, but we can figure this out since I know a point and the derivative. Just like the other questions, in order to find the original function, we take integral of derivative function. So our derivative is 1 over x. Whose derivative is 1 over x? The ln's derivative is 1 over x, right? So we have ln x plus c. Now this is my original function. I don't know what c is, but thankfully I have a point. I'll put this point back in this function. So my point is e squared 1. My x is e squared, y is 1. So 1 f of x is 1 equals ln x, which is e squared plus c. We can use this property of logarithms. Ln e is 1, So we are left with the power. So we can write this as 1 is equal to 2 plus c. Then moving 2 to the other side gives me negative 1. I got my c. So my function is ln x plus minus 1. This is my original function. Now I'm going to evaluate this function at 1, right? So what is f of 1 then? Replace your x's with 1. ln 1 minus 1. ln 1 is 0. 0 minus 1 is minus 1 is the answer, which is option B. Alright. One last question. No, not one last. Two last. Another exercise question. This is also an original question. And there's also administrative question similar to this one. Find a function knowing that it's continuous and f of 2 is equal to 6. Okay, we need to find a function. We have a point. We also have its derivative, just like the other questions, right? The difference is we have a piecewise instead. So steps are same still. This is the second part. Let me say this is A, this is B. So part A. Okay, that we are looking for f of x. We will do that, find that by taking integral of f prime of x. Okay, f prime is given as a piecewise function, 1, 3x. 2 is less than x, less than 5. Okay, now let's take integral of each part. So f of x equals integral of x is 1 is x plus c. Integral of 3x is 3x squared over 2. Okay, I got my original function with c's. I don't know what c's are, but what I know is f of 2 being equal to 0. If a function is continuous and f of 2 is equal to 0, then limits as x approaches to 2 from left of this function must be equal to limits as x approaches to 2 from right of the same function, which also must be equal to 6. This is chapter 2. If there is a continuous function, then right side limit is equal to left side limit is also equal to the value of the function at that point. Okay, they're all equal to each other. So now use this information, okay, to solve that question, to find c's. This point will help us to find c by finding the left and right side limits. Let's do that. Limits as x approaches to 2 from left of f of x. From left, this the first function, x is less than 2 is the left side condition, x plus c equals 6. Then when you give 2 to x, 2 plus c is 4, then c is minus 6, right? So I got, no, c is 4. This is 6, c is 4. Okay, I got one of the c's. The second c, let's check the right side limit now. Limit as x approaches to 2 from right of x is bigger than 2 will give you the right side limit condition. So the second function, 3x squared over 2 plus c, so is equal to 6. Then substituting 2, 3 times 2 squared over 2 plus c is equal to 6. 2 and one of the 2's will cancel each other. 3 times 2 is 6. 6 plus c is 6. Then c is nothing, it's 0. Now I got c's. I'm going to write the function with the values of c's that I found. F of x is equal to x plus the first c is 4. Second c, 3x squared over 2 plus c, which I found as 0. I can say this is first C, this is second C. First C, second C. Okay, this is my original function. I answered the first part of the question. But there is one thing to be careful. We are said that this function is continuous at 2. If it is continuous, we have to equalize x to 2 in one of the conditions. Either here or here, we have to put equality because we are sure that the function is continuous at 2. It should be equal to 2 in one of them. Okay, I got the answer. This is the first part. Okay. What about the second part? Second part is asking if it is differentiable at x equals 2. Chapter 3 this time, differentiability. Remember how to check differentiability of piecewise functions. If a function is continuous, which is, we find the derivative, which is already given, and check the limit from right and from left. If the limit from right and left are equal to each other, we say it's differentiable. If not, it's not differentiable. So let's check this f prime out. F prime of x was 1, and what was the other one? 3x. Okay, now since I have the derivative, let's just take the find the right and left side of the limit for 2, which is equal to 1 for the first one. For the second one, limit as x approach to 2 from right, x bigger than 2 condition, which is 3x. Substitute 2 back, it's going to give you 6. So 1 and 6, they are different. Limit as x approaches to 2 from left is not same as limit as x approaches to 2 from right. So we say limit does not exist at 2, then limit as x approaches to 2 of f of x does not exist, then f of x is not differentiable at x equals 2. Answer to the second part. All right. This was such a nice question. It involves a lot of things at once. There's one mystery question regarding this. Okay, one last question and I finished the lesson. Okay, another similar question, a combination of integral and limit like the previous one. We have the first derivative, a point, and the original function is missing. Okay, as usual, in order to find the original function, take the integral of derivative function. So my derivative is 2x minus 1. Now, integral of 2x minus 1. Integral of 2x is 2x squared over 2, which is x squared. Integral of 1 is x, and I have plus c. Now, use this point. What is the point? Negative 1 for x, 5 for y. Negative 1, 5. So equalize 5 to the function with negative 1 for x plus c. So 5 is equal to negative 1 squared is 1. 1 minus minus plus 1, 2 plus c. Then my c is equal to 3. Right? So I got my original function as x squared minus x plus c, which is 3. Okay. Now it's time to solve the question. I got my f. Take the limits. Limit as x approaches to 2 of x squared minus x plus 3 over 15. Direct substitution. Let's substitute 2 for x. 2 squared minus 2 plus 3 over 15. 2 squared is 4. 4 minus 2 is 2. 2 plus 3 is 5. 5 over 15. Simplified. Divide both sides by 5. 5 over 5 is 1. 15 over 5 is 3. So I got an answer. 1 over 3. Okay, that was also such a nice question.